Hello, everyone. Welcome to our 20th DataGrok user meeting. Time really flies. I think it's been 5 years since we started the series, maybe 4. I need to check anyway. There's been many of them, and today we have some great content as usually. So here are the topics for today. First, I will walk you through our new and improved visual query builder. And then Pavlo will show how we can run scientific computations in Python completely on the browser side, which is really cool. Then Alexandra will present our open source project Admetica, which is an open source predictor of ADME properties. And to conclude the meeting, I will take control again, and I will show some ongoing improvements for scatter plots. So I hope I will be able to surprise you a little bit here. Anyway, let's get started. If you have questions, please do ask and interrupt. Let's make it interactive. And let's start with the database queries. So, as you know, dealing with data is important in general, and this is what DataGrok does. So here we've grokked an easier way to construct queries for databases visually. And the problem usually is the following. Of course, you can use SQL, but really typically schemas look like that. Here I'm looking at a Campbell schema. Well, yes, you can write it, and even you have some assist with it. And we provide a nice way to see the content, including some chemical content that gets recognized on the fly. So we do a lot. But still, writing queries could be very time-consuming, especially if you don't use the same schema over and over every day. So what we did, we simplified this process a lot. And don't worry, I will be showing it on a simpler schema than Campbell, so that you will be able to follow what I do. But you can do the same in really complex scientific schemas.
Just a quick question. Where does this instance reside of Campbell?
Well, this particular one is on our development server. There is one in J&J, and I think it resides in J&J. It was just part of our deployment datasets. So each instance has its own. Depends on the configuration, but essentially you can always right-click and see what the database is. So yeah, just check.
Is that the latest version of Campbell? Just interested.
I think it's version 33, so probably the one before the latest, but I'm not sure, Dima.
Okay.
We did upgrade. I just don't remember if we upgraded to the latest or to the previous ones. All right. So let's take a look at a much simpler schemas that Microsoft likes to use in their demos. It's called Northwind. It's a very simple schema with just a bunch of tables, your orders, order details, employees, countries, territories, and so on. So let's look at the orders. And yeah, by the way, as you can see in DataGrok, you click on something and you see stuff immediately. It's really helps it. So let's say I have orders and I want to explore. I want to add more information to it. I want to construct some queries where I want to use orders as a base. I would right-click, as I would typically do on DataGrok objects. And here we have the new visual query thingy. Well, out of the gate, we construct a visual query that returns all fields. In this redesigned UI, we have an easier interface for choosing which fields we want, basically, initially. So let's say I'm not interested in the address and order date, also not of interest, not the codes, again, not the date. So let's just make it slightly smaller. Like that, yeah, takes a second, less than that. But let's see what else we can do with the query, what other data we can bring. And here we have an icon that lets you join data visually. When we click on it, we see a menu with a separator. Here, the items represent tables that could be joined on any combination of keys between the original table and the next table. And on top, we have tables where we know in advance the key, where we have the foreign key relationship that we extracted from the database schema. So these we can join really easily because the database schema author has defined essentially the joins. And to do that, I can simply go to the table that I want to join. And for instance, this is the employee that processed the order. And I want to see, well, okay, who was that? Bam, we got it. What was his title? Done. Okay, how about the shippers? Who shipped it? None. Okay, what was the customer? Just like that. It makes you the process of constructing queries super intuitive. It's a really nice middle ground between typing queries completely in free text, which is great and no way sometimes around it, but sometimes for experts. And what's also coming in DataGrok and other tools have it, constructing queries based on a free text query, such as show me employees who shipped orders to France. Behind the scenes, we would also generate the query in the next version or the following one. But you also need to be careful around it. And this middle ground is nice because it lets you operate quickly and you know exactly what's happening. You can also see the SQL query underneath. What else we can do with it? There is now a convenient UI for filtering the results on multiple levels. So if I want to filter rows that in the source rows, I would click on the where sign, and let's say I want to filter on freight. Yeah, why not? Where is it?
I believe you haven't chosen column.
Okay. Yeah. Thanks, Paulo. Indeed. Okay. We have, okay, this is the column. That's great. And in this field, you can type condition in a free text with also a little bit of help that lists the supported operations. So typically, you want some basic arithmetic operations, for instance, greater than 10. Bah, we got it. Greater than 50. Got it. Or let's say I want something from 30 to 50. Done. Pretty nice. If I want to combine conditions, let's say I want to combine the phrase with the country where the order was shipped to. Let's say France. Done. Or no condition, it's yeah, no filter. In
And this is an ANDed combination here?
right, yes. At the moment, it's also always ended. In the next version, we will provide some more flexibility around it. So most likely we will only have the AND or switch, because otherwise the UI is becoming prohibitively complex. You will still be able to write it in SQL. But yeah, exactly. Currently, it's only AND. We can also group stuff by. So for instance, let's group by ship country, and let's aggregate. I want to aggregate the sum of freight shipped to that country. Done. I can also pivot if I want to put values in columns. The last one item that became available after we grouped by is another filter that filters not the source rows, but the already aggregated rows. So here I can also, and by the way, here we have available columns that are not necessarily in this query or in the resulting query, but underneath, behind the scenes, they would be used for aggregation. So yeah, I can also type any sort of filter here. Let's then see how we can use it as a user. So this interface, it's sort of in the middle, I would call it, between regular user and power user. Typically users can use it, but also people who develop queries and dashboards can use it and can expose it to users who don't want to know about database schemas. They just want their data given the parameters that they provide. So let's see what we can do with that.
I have a couple of questions. So first of all, as you can see, it says in the upper right corner, limited by 100 rows and 13 columns. So if I actually want the entire result set, how do I
get
the
great
entire
question,
table?
Dima, you notice very a lot of things. Yeah, you will just run it. So this is for preview purposes only, because you typically want just to get the shape of your result when you construct the query. When you run it, yeah, you'll get full results.
Also, when you're showing the preview, is it synchronous or asynchronous? Because with toy databases, it all works great, but if you have a really large database and construct a query, it takes a while to execute. Will it hang and show an hourglass, or what's going to happen if you edit if you construct that query visually and some step takes like a minute to execute on the database? What's going to happen in that case?
Well, we will issue all queries in the interim, but only the last one would show. So pretty much the same interface as, let's say, when we do freight greater than 30. See, it gets grayed out, and then you see the end result. But that's a really great consideration. I believe we do have some heuristics for long-running queries, because sometimes, if you see that queries run for a minute, you probably want to adjust the way you send them. We have something in it. I can go into more details with you on that later, but great question.
Yeah, and also, do you allow for outer joins?
Another great question. Thank you, Dima. Yes, we do have ops. For some reason, the outer join is not here. Pavlo, any ideas why we don't have outer joins?
Well, it's by the way, it looks like by default you're actually executing the left outer join.
I think it's left inner, but okay, let's
well,
figure out the
inner cannot be left or right.
Okay, then it's left outer. I think you're right. All right. So yeah, anyway, yeah, that was a good thing that I missed. You can also define the type of the join. Well, you can tell.
Okay, so by default you're doing the left outer join essentially.
Yes. Yeah, which is typically what you want. Yeah, you get everything from your left side, but also.
Yeah, I think it's actually a reasonable choice, frankly. I mean,
Yep.
You would, as you construct, you would want to see all the rows. Yeah.
Exactly. Yes.
But there should be some kind of indicator. I think it's that little circle with the arrow in it, right?
Yes.
Basically
If I
says.
change it, yeah, it would also change. Yeah. Yep.
Okay. Yeah, I think it looks pretty good.
Yeah, thanks. That's just the beginning, Dima. So let's see how we would use it as a user then. So now we are in our power user mode or developer mode. So let's take a look at these checkboxes. They allow you, so if you remember previous demos of Datagrok, and in general, the concepts, everything is a function. So this query becomes a function. But what are the parameters? If we check that box, the filter condition becomes a parameter, and you'll see it in a minute. Let's also check this box, and it becomes an outer parameter exposed to the function as opposed to the just internal details of the query. But let's also say I want to change the visual layout, and this is the view. I want to have some, since it's retail, of course, pie charts, yeah, bar charts. Let's be slightly scientific with scatter plots. And yeah, let's call it something. Let's call it the UJM orders. And we will save it. And now, if we go to, if we find that query, it actually has the parameter that we exposed plus the dashboard that we have built. So if you change something like no parameters, bam. And as an end user, very often this is all you need. And look at the URL. You can send it to your colleague. This is the identifier of the query that we just created. And this is the parameter. Let's say I want something else. Yeah, you copy paste it, you execute it from the other browser. Yeah, and in a second you'll get the same. And we did all of that visually. Yeah, there are a few other details on that query wizard that I did not explain, but I think that's enough to get the idea. We will also be coming up with plenty of improvements, such as automatic drop boxes for filters where we know that the column is categorical. So for instance, you would be selecting between countries, France, Spain, and so on, and things like that. But that's the start. And what you see now is already available in the version 1.24 that we have released a few weeks ago, maybe a month ago. All right. Any
Andrew,
questions before I move on?
Excuse me. Yeah, I think it's 1.23, 1.24.
Oh, I'm sorry. Yes, 1.24 is the one that we built. There will be plenty of cool features, but next time.
So you had mentioned that, you can use this UI to start to build your query. Obviously, there's SQL in the back end here. Is there a way for you to start it? And then if you need to refine the query beyond what the UI allows you, that you can pop to the SQL window that allows you to continue your refinement using, standard SQL syntax?
Yes, I believe we do have it. At least it was in the requirements that came from me. It was not my feature. Pavlo, did we implement it this time? Can we go to SQL from this view?
Yeah, you can click on property panel, click on query and click query.
Okay, yes, you got it. So a little bit clunky way to do it. We were planning to integrate it with in this mode, so it would be easier to go. But or you can click here. Yeah, that's also a way. So yes, Ed, you can do it just like that. You can copy paste it. Go to browse, right click and say add query, and you would paste things like that.
So what's going to happen if you're in the designer mode with that visual form and start editing the query in that window?
I don't know, Dima, don't do it. You know, like Steve Jobs regarding holding the phone. Don't shoot yourself in the foot. Nothing good can come out of it.
No, I mean,
Okay.
is it the two-way communication or just one-way? So from the query designer, it gets here, but if you start editing,
It's
well,
not editable. I am trying to hit
it's not
delete.
editable.
Yes.
Ah, okay. So if it's not done,
It's
But
not
I-
synchronized. So
I adore your attention to details. All right. If there are no more questions, let's move to our next exciting topic. And Pavlo, I'm
the last question about this query designer. There's a save button, but once you're in the designer mode, the save button, what does it do?
It persists the query. So yeah, you can play around as much as you want. Sometimes you just want to, you know, explore the data and not even save the query. But when you want it to save, and then you can share it with other users and so on, that's what the button is for.
Mm-hmm. All right, sounds good.
Mm-hmm. All right. So yeah,
I'll try to play with that feature using a much larger data set and see how it works.
Thanks. Yeah, very interested in your feedback as usually. Yeah.
Yeah, regarding large data set, I can add that we only prefetch small part of the data itself. That's why it will be rendered fast. So it doesn't matter how big data is. Also, we stream data by chunks, so you can see your data set immediately, and you don't have to wait to execute whole query.
Yeah, it's just that sometimes it happens that even to prefetch a very small data set, if you have a very complex join, it's the join itself, especially if the database is not designed properly and missing some indices, you know, even prefetching can take like considerable time. I mean, that's why I asked that question: what would happen if preview takes a long time to construct? Is it gonna like freeze the interface and wait till the query finished before you can do anything
I understand your
further?
question and your concerns, but no, interface won't be freezed because it's fully asynchronous and
Okay.
yeah.
All right. Looks pretty cool. So well, I'll play with it once it becomes available with our update, I guess, for J&J.
I hope you can see my screen now. Yeah.
Yeah.
So hi everyone, my name is Paulo. I'm working for Datagrok as a software developer, and today I'm going to show you the new cool feature that will make your Python scripting experience much faster and efficient. Datagrok currently supports a lot of server-side scripting languages like Python, R, Julia, Octo, and server-side scripting tends to be a little bit slow. That's why we use JavaScript to create dynamic dashboards or to perform fast column calculations. But come on, JavaScript DataGrok is designed for data scientists, and we all know that you data scientists prefer Python. That's why I'm happy to announce that we have integrated Pyodide. So what's Pyodide? Pyodide allows you to run Python scripts directly in your browser, allowing ensuring fast performance and data privacy. You can always familiarize yourself with Pyodide using their official website. I won't stay here for long. I'll go back to our platform and let's run a Python script and compare its execution time to Pyodide. I have already prepared some script. It's really simple. It accepts image, processes it, applying different filters, calculating edges, and then it plots to graphics. Also, I have prepared image for this. And let's just click and run using server-side Python. We see it took some time, but it was solid. We've got our two images, two graphics. Let's close it and let's run it using Pyodide. You just need to change one line of code to run it as Pyodide. Just change language annotation and that's it. Yeah, let's run it. Let's choose the same image and click OK. And we've got our result, and it was much faster than server-side script in Python. As we see, Pyodide is similarly integrated into our platform, so we can always use our menus to create Pyodide script, and also you can use scripting view, and also choose here Pyodide script to create Pyodide script. Yeah, let's move to another example. I have prepared dashboard. It uses scripting viewer. This scripting viewer is based on Pyodide script, and it renders counterplot. I have here a small data set, and yeah, let's play with it. We have filters. Let's change them. As we see, our plot changes accordingly, and it changes much faster. And we couldn't achieve the same performance if we use server-side scripting. Yeah, it's really pleasantly. It has really blazingly fast performance. Let's talk about some limitations. Currently, not all of the third-party packages are supported. Of course, main packages like pandas, numpy, pyplot, as you saw, and ML packages are supported. But for instance, some specific bio or chemistry packages are not. And we are currently working with Pyodide team to add support, and probably in the future updates, they will be supported. Also, Pyodide is executed only in one thread, so it's single-threaded. That's why when you run several Pyodide scripts in parallel, they will be executed sequentially. In conclusion, I want to say that from now on, you don't have to worry about JavaScript, and you can use your native language Python for building dynamic dashboards, for post-processing query results, or for making fast column calculations. That's it from me for today. I'll be glad to answer all your questions.
How do you access data in the underlying table from a Pyodide script?
Yeah, it has directly.
I just didn't have enough time to like glance over the source code that you showed. So how do you access the data in the table?
Yeah, Pyodide runs in separate thread, and it based on WebAssembly. We pass data to WebAssembly, run the code. Basically, there are some specific conversations under the hood, and you don't have to worry about them. So, yeah.
No. What I mean is that suppose I have a table on Datagrok and I want to process it with a Pyodide script. How do I address the columns and the rows on the current table from the script?
Yeah, I understand now. Yeah, our data frame passed as pandas data frame. So you use all the pandas methods that you want with data frame. Basically, let's create just template script. You see here is input table data frame, and we use here pandas method. So just pandas table.
So there'll be so table is gonna contain a copy of all the data from the current Datagrok table,
Yes.
correct?
Yes, correct.
Okay. So I see it. Yep.
And so how is version management handled? Pyodide, versions of Python and packages, etc.
Yeah, so Pyodide itself provided by our plugin system. So it's separate plugin. You can always enable and disable it. Here we have scripting section in plugins and Pyodide. But regarding version of Python, I don't want to make any mistakes, but probably it's 3.12. We should check Pyodide's documentation for this, but probably it's one of the latest one. So about packages, they are also using latest versions of the packages. So when you import some package, it will be latest version of the package.
Yeah, I can add a little bit of context. I'm also following the Pyodide development, what the guys do, and that's a hot topic currently, the way they support external packages, and they are changing different ways to make it simpler for the community to both compile the ones that need compilation, meaning when you have C++ code and some native code inside, and use different packages. So currently, I would probably use it for typical data cleaning, and as Pablo said, very useful for data transformations, query cleanups, and so on. As a data scientist, you're a lot more comfortable with Python. So it should be enough to just use pandas, numpy, scipy, and so on. I expect that in the next versions we will have more packages converted, including, of course, RDKit. Once that is done, we will be able to access a wealth of scripts regarding to Kim Informatics, and we wouldn't have to rewrite them in C++ and then compile, what we do currently. So now, well, once it's done, if we see some interesting scientific method, it would be pretty much a copy-paste. I'm very enthusiastic about it. But yeah, to answer Ed's question shortly, probably there is currently no easy way to manage complex dependencies, but it's coming.
Okay, well, again, let's 2 thumbs up for enabling this, because this does, unleash some great capabilities here to try, and can't wait to give it a shot. So.
Okay, yeah, thanks, Pavlo.
Right, thank you.
Yeah, I'm very excited about the Pyodide development. Sometimes we might present R in the browser, but yeah, let's start with Python. And our next presenter is Alexandra. Alexandra, just a second. And you are a host now.
Okay, thank you. Let's start. Thank you all for joining us today. My name is Alexandra, and I'm a scientific application developer here at DataGrok. And today I'm going to talk about our open source initiative, Admetica. So why we actually created Admetica? We know that around 90% of drug candidates, they fail due to poor pharmacokinetics. That is why we understand that for everyone in drug development, ADMET prediction is really important and needed. Yes, there are some commercial solutions, and big pharma companies have their own tools, but unfortunately, they are unavailable for the whole community or unaffordable for small labs and academia. And of course, there are some publicly available tools, but they also have many limitations. For instance, some of them are not entirely open source, or even if they are difficult to use, or for example, they have some issues with data confidentiality. For instance, I'm sure that when you are developing new compounds, you don't want just to upload them to an external web service. So that is why we built our own Admetica, and we made it fully open source. And I mean everything, so the data, the pipelines, and even the models. So everything is open source and in one place. But we didn't stop here, and we even made it production ready. What it means, so you can use it as you need. For instance, through the command line interface, or as a web server, or even as a foundation to build your own proprietary ADMET tools, whatever. So right now we use chemprop modeling engine on top, though there is a flexibility to mix and match different models. So, and I want to note that this is just the beginning of our journey, and we are collaborating with the industry and academia in order to make it even better than it is right now. And our primary goal here is simple. We just want to make Admetica accessible to everyone. So yes, and maybe you're wondering whether we integrated Admetica into the DataGrok. Yes, we did it. So, and while the DataGrok is a commercial platform, it's free to use for the research individuals and academia. So I think that they can get all the benefits of using it inside the DataGrok. So I guess now that's enough talking, and let's come to an action and see how it works inside of the DataGrok. So as Andrew said in the beginning, everything in DataGrok is a function. That is why we can use Admetica seamlessly across the platform. We can add new columns with predictions. We can use it our apps, and so on and so on. For instance, I will open our heat triage app. So this is what medicinal chemists use in their heat selection workflows. And now they have an opportunity to add ADMET predictions alongside with their other calculations. And it's incredibly easy to do. What you need to do is to click on the range icon. So a compute dialog here appears. We need to find the Admetica HT option and select what we want to calculate. Let's calculate expression, for instance. After clicking OK, the results will be added to the data frame in just a few seconds. So you see how quick it was. Let's see what else we can do. For instance, watch this. While drawing, the DataGrok is calculating in real time. So you see. And you can see that it flags this structure as highly toxic. Let me remove this and this. And stop. stop it. It just had to work in another way. So let me remove it. And right now you can see that our structure and the toxicity just drops immediately, and the color coding helps us with that. Let's be more ambitious and calculate the ADMET properties for the whole data set. We can do this, of course. For that, we need to navigate to Chem, Admetica, Calculate, and the dialog opens. What we have here, we need to pick a data frame, column with molecules, a template, number of properties to calculate, and some visual preferences. Let's stick to our templates. We understand that there are different projects, and for different projects, people need different settings. So here, for instance, you can configure your visualizations. So you can pick where the lower values are better for you. You can choose the interpretation. For instance, high values will be more than 80, and they will have not the blue color, but maybe, I don't know, red. Maybe it's bad for you. So you can just change whatever you want. So we are as ambitious today. So let's just choose all
Alexandra, maybe
properties.
a little more context here I'll provide. So it's not for the visualization. Essentially, what this template defines is the ideal profile for your target, for your ligand. So not for the target, for the ligand. Because depending on what you want to design, sometimes you want to have different properties, and there is no absolute good or bad. So that allows you to specify, well, I want my lipophilicity in this range, and blood barrier should pass, or the other way. And this is exactly what this template is for, so that it connects the goal for the drug design with the calculator. And later on, we'll see how it is used. And we also have other tools in the pipeline that we are not presenting today that use the same concept. Currently, today is more for visualizations, indeed, like Alexandra said, but the concept is a bit deeper.
Yes, as Andrew said, we even analyzed all the properties, and we have checked whether there are definitions that are as a constant and people won't need to change it. But of course, yes, there are situations when we don't know whether for someone this and this value will be better if it is lower or higher. That is why in such cases, we give an opportunity to set up everything depending on your use case. Yes, that is totally right, but just in the context of this presentation, it's maybe more about presentation. Okay, let's click OK and wait just a little bit to get our results. Yes, here they are. So I want to show you today 3 cool things. So first, look at the pie chart. It is called the Vlaavis chart. So I will show you it in a bigger mode. So these sections here, they actually represent different ADMET properties. And you may see that some sections, they are extending past this light colored border. It means that these sections have strong characteristics. And this pie chart is really a good thing to explore your data set in a quick way and to find the compounds of your interests and promising compounds, whatever. In addition, the second thing I wanted you to check is our groups. So here, I will make this a bit less. So here you can see that we have properties grouped by a category. So that is pretty impressive. I really like it. And in addition, you also may see that these properties and this group, they are colored the same way as in the pie chart. For instance, here we have Kakutu property, and this is the same here. the same blue color there in the pie chart. It makes your interaction with the whole Admetica tool even easier than it was. In addition, in the grid, we have color-coded values here and tooltips that appear on hover. What for it is needed? This is needed in order to get this instant interpretation. So here we can see, for instance, some structures have good capital values, some have bad, and everything will be configured based on the template you will provide in our Admetica dialog. So instant interpretations are really good for you to analyze. And I think that
sorry, I was
yes.
just saying yesterday with it, and yeah, I moved over toxicity column, and it was saying could be dangerous if swallowed. Pretty. I did not even expect that level of detail.
So yes, we've analyzed a lot of resources in order to come up with a range and their descriptions that people are using for admin. So all the information is right. So you can change it if you want. Up to you. Yes, and I think that is all what I wanted to say. And in conclusion, so Admetica right now provides reliable ADMET prediction with their analytical tools, and they are available for everyone, whether you're in a big pharma, in a small biotech, or academia. So it's open, it's flexible, and it's ready for your workflows. And I can say that right now we are really excited to develop this community. And if you are really interested in what we are doing, you're welcome on our GitHub page, and you can contact us and get started with Admetica in the Dataproc. So as you wish. So would like to hear your thoughts and questions. Thank you for your time.
This particular structure looks familiar. I think it's some kind of antiviral drug, but funny thing is that LD50 is 0. So, I mean, it's so toxic that we should be all dead by just looking at this structure, you know, already. So the obvious question is, what's the underlying model that predicts all those ADMET properties, and how is it trained?
Chemprop. We are using Chemprop engine to build all the models.
Is that the one from MIT or?
If I'm not mistaken, yes.
Yes.
They have MIT license. Yes.
Oh, not the license. It was actually produced by MIT people working.
Oh, yeah.
Yeah.
So yeah, we collected the data on our own. It was just a big job done here, and we are using right now the newest Chemprop version. So this is better than they had before. So the newest Chemprop version under the hood.
And it's trained on publicly available data that we gathered from multiple pieces, including, I think it's Therapeutical Data Commons, the one that
yes,
for competitions and so on. But also we've extended it by, yeah, would you like to talk about it, Alexander?
I just wanted to show the structure for people that didn't see it. So here we have models. Here we have the data set that we've collected, but then we pre-processed it before giving to the model. And here you can check the pre-processed resulting data set that has been used for the modeling. And from what I understood, Andrew started talking about Novartis models, yes, that we've enhanced.
Models data, yeah.
Novartis data, but they had their predictions too, but we had to spend enough time. So, okay, we even have a section here on our ADME. So the scientists from Novartis, they published a paper in Nature with ADME predictions, and we wanted to compare their results and our results in order to understand whether we can enhance our models with data they have, because they have like you see 2,700 molecules in their data set. And it's really impressive because publicly there are no like even 20,000 of available structures with predictions. It's really hard. And even several models here we enhanced using the Novartis data. So yeah, there are even some results here. Some were obtained really good improvements. So, and I think that some of our models are even more reliable than they were before when we started this initiative. And in addition, we also evaluated other free online ADMET tools in order to provide you with information that our tool is reliable. And even here we also took a supplementary material of the study, and we analyzed our results with other open sourced tools like ADMET Lab, ADMET, pre-ADMET. So, and our results are pretty good actually here. If you want, you may check it. So for instance, here the accuracy is pretty good. We are in the second place after Admetica. So, but yes, we even had a comparison of the tools with our models that we provide. But our Admetica is much better because we have everything open sourced. And for some, it's really hard to find their models, their data, what's under the hood, and you just try to guess. And it's really hard. Here you can take it and continue working.
Mm-hmm. Yeah, sounds pretty interesting. Of course, all these models need to be taken with a grain of salt, you know, because all the structure-based property predictors have their limitations, especially the ones that are based on just the structures themselves, because they have no way of taking into account some peculiar chemical features. Some of them, for instance, totally ignore stereochemistry. Some of them, which plays a lot of roles, you know, in biological and physicochemical properties. Then some of them totally ignore tautomers, which are in fact completely different chemical entities with different properties, and depending on particular conditions and biological systems, one of the some particular form or tautomer can be prevalent, and sometimes people predict properties for a totally different tautomer. So I'm a little bit skeptical about all such models, but that's basically what it is.
Yep.
But still, you can use it in a mix with our heat triage. So there are a lot of other properties that can be calculated, and you just can do this quick analysis of whether the model is right or not that right. So just to compare and see.
In my opinion, the only property that can be very accurately predicted is the molecular weight.
Well, yes, but you know, people nevertheless do it with some good results as well. And as Alexandra said, one of the main values that we see in this initiative is to establishing an open source end-to-end production-ready pipeline and a model that you can take and enhance in any way. You can add your own proprietary data and retrain it. You can mix and match models. You can do pretty much anything, and you don't have to start from scratch. We got already the servers that return the standard format and so on. And then, of course, yeah, a lot of effort went into integrating it with DataGrok so that it's always convenient to use in multiple contexts. So even if a company wants to use their own either proprietary calculator or commercial one, it's pretty much trivial to take its results and massage it into the way Admetica on the data grok on the client side understands, and you would get all of that rich functionality with your own proprietary calculator, which we thought was also cool. So we did, and Alexandra did fantastic work here on multiple levels. Yeah, really excited about that initiative. We will be talking and advertising it in corresponding communities soon. Yeah, thanks, Alexandra. Great presentation.
So the entire source is on GitHub, right?
Yes.
Including the trained models, as far as I could see, right?
Yes, and there
Yeah.
are even some notebooks that may be helpful.
Yeah, I'll take a look at it. I'm curious how it actually works.
Yes, please do, and yeah, let us know what you see. All right. And then, if there are no more questions to Alexandra, yeah, I'll show you some things that we built for the scatter plot recently. Well, I think we've already mentioned scatter plot in several demos over the years. As you know, it's one of the most basic, most widely used visualizations in science. So it has to be good. As you know, it already had hundreds of features, and today I'm gonna show you a few different adjustments and capabilities. So first of all, now we support whiskers. Essentially, very often in scientific data, you not only have the exact value, but you also have some confidence interval. For instance, here we take the measurements, but also we have minimum and maximum. Now, if you open scatterplot, Datagrok automatically recognizes that there is data in a data set likely annotated with ranges and shows it appropriately. It can be turned on or off or set to multiple other columns. Everything is customizable, of course, but out of the box, you would get automatically what you probably expect. So relatively minor, but nice feature. I'm going to the next feature in a second, unless there are questions. Good. Yeah, pretty simple. Then, very often we deal with relatively big data, and Datagrok shines with processing data up to a few gigabytes completely in the browser, and that allows really unmatched performance. So now we've supercharged our scatterplot to work with massive datasets. This dataset is 10 million rows. Let's scroll. 10 million rows. And here it is in the scatterplot. If you do notice any sort of lag or delay, well, that's the zoom. Let's blame zoom because I don't see it. Everything is super smooth buttered. You can still use any parameters, change sizes, jitters, markers. It would run fast. It was not easy. We did a fallback and did some black magic using web GPU. And what's important now, scatterplot can render both very specific stuff like whiskers, molecules, all sorts of jitters that are hard to do in WebGPU, but also can render massive data sets. Currently, I think in version 124, this feature is turned on, but in the version 123, it might be still under the beta flag. And to enable it, in case you use 123, go to Settings, Beta, and check the scatterplot web GPU acceleration. Next great feature. So now we've significantly improved our support for labels on scatterplot, especially for molecular labels. So I'll jump straight to molecular labels. Let's say we have a data set with smiles, with molecules, and we want to, what do we want? I want to see the chemical space. Again, it's our supercharged fast UMAP method. We don't build slow software at DataGrok, as you see. Now, by default, not only it has produced the chemical space using fingerprints and dimensionality reduction and distance functions. That's not the point. We described it earlier, but now by default, it shows labels for the molecules, which lets you quickly identify what sort of clusters we see, right? Previously, you would see the clusters, but you had to click on each one or hover and see what sort of molecules live there. Now you see it immediately. The way this feature works, it tries to position a reasonable number of molecules around your datasets. So pretty much perfect for that sort of exploration of molecular datasets where you expect or want to find some sort of pattern. It's highly dynamic. As I zoom in, see more labels appear. So yeah, if there is no space for something, you zoom in, you still see them. Super convenient for chemists. We've already got some kudos from a couple of users. I think
if you hover over the structure, does it increase in scale so you can see the details?
Not automatically, but that's a good suggestion. That currently you can
Because there are really two
over...
things that I see here. One is that you can do it is great, but then I think about, well, is there a hotkey or shortcut to toggle them off and on so you can see the whole shape of the data and not get confused by the labels, you know, and focus those in and out when you want to. So.
Yeah. Yeah, we made it simple. So there are hundreds of little changes and improvements in the platform and in the viewers. So one of the themes that we started implementing is context menus everywhere. So for instance, you would click here on a molecule and you see options specific to the label. So you see what I want to show, like nothing, right? Or I want a molecule plus its ID. And it's intuitive. You don't have to dig in the menus and look for it. Same for instance, if I color by something, I think, yeah, I can, maybe that's not currently wired up. So if you right click on an element, you would see menus corresponding to that element. Yeah, the same thing here. You can play with different options, yeah, depending on what you want to see, or maybe you don't want to see anything. We do it by default only for things where we think you would want to see all structures, such as chemical space. See, if you just open scatterplot, it does not add labels automatically. But if you add scatterplot, there is also another cool feature which lets you manually select molecules or points. It does not have to be molecules for which you want to show labels. That was a very requested feature from one big pharma companies, where scientists very often take screenshots or copy viewers and then present their results to a wider audience. They wanted molecules to show the exact molecules that they selected and also the exact positions. And this is how it works. You would go to labels, select what we want to see. Yeah, in this case, smiles, and we want to show labels for selected. In this mode, you can select a bunch of molecules. By default, we arrange them using some heuristics automatically. And sometimes they would overlap inevitably if you select too many. But now a chemist can just drag and drop them just like that. And for instance, if you have some groups or you want to compare things, you can do it in that very visual way. Yeah.
I do not
Nice.
know whether it would make sense to add the option of making all those areas containing the labels, in this case, for structures semi-transparent or not. Would it confuse users or not? Because you sort of, they hide the large chunk of the underlying scatter plot.
Mm-hmm. Yes, we played with that idea. I think in the end we decided against it as it was not looking too good. It was looking dirty. We played with different levels of transparency. Sometimes we do use it. So for instance, here, let me try to show it. Yeah. So this column selector, it shows some transparent stuff underneath. Maybe we should do a very similar thing. But yeah, currently for molecules, yeah, we decided not to pollute the picture. We might revisit this decision.
So when you toggle the option of showing all showing those labels for all data points, how does it decide which labels to show? Because if there are too many points, it'll totally kind of cover the entire area with labels, right?
Yeah, I think in this case we are smart. So when we know that it's going to be a huge mess, we only show labels that would fit and not cover everything. So yeah, there are some heuristics to prevent users from doing things that they definitely don't want to do. One interesting thing, and let me show it to you. So for instance, you can do the mouse over group thingy, and then if, for instance, if we have it somewhere on a histogram, but let's use, okay. And now when you hover over stuff, I don't think we have enough space here, but you would see the corresponding columns, so which could also be quite interesting. Yeah, I think in this mode we also should show all of them. That's one area for improvement.
Yeah, of course, if you combine the visualization of a chemical space with clustering, it would make sense to show the centroids of the clusters. I mean, the labels for the centroids of the clusters. But then again, there are like multiple options for choosing them. But
right,
but
yeah,
with large chemical spaces, I think if you try basically to show all labels and use some heuristics to show only the labels do not cover the space completely, then you'll be missing a lot of useful labels.
Right. Well, yeah, showing the centroid would work great if you know in advance that the way the algorithm has clustered data, different chemical groups collapsed into different clusters, right? But sometimes it's not. And by showing more labels, you can profile that. So yeah, it's a balance in this case, and yeah, we always tweak the implementation to be the most intuitive by default to chemists, but yeah, sometimes you pursue different goals, which we don't know in advance. Yeah, that's when it's interesting.
Yeah, and obviously, if you, I do not know if it's all possible or not. I mean, the opaque areas around the structures and the labels are rectangular. You can sort of increase the visual space underneath if you make them non-rectangular and essentially just kind of some kind of closed curve enclosing the structure with the minimum taken area. You know, I do not know if it's possible or not.
Well, it is. Yeah, we do pretty hardcore stuff, so it's possible. Interesting idea. We did try to show them in circles and ellipses with mixed success because sometimes the structure go to the corners. We, at the very least, we can do rounded corners. But indeed could be interesting to do what you suggested. That did not come to my mind earlier. Thanks, good idea.
Yeah, it's really hard to implement it in such a way that it works in all cases. Because sometimes you'd want to see the entire space and the density. By the way, I totally forgot you asked that question when you were showing scatter plots on with large data sets. Does the plot actually reflect the density of the points in a particular area?
No, each point is rendered individually, so really 10 million points individually. We do have a density plot, which is a separate plot. Yeah, that we recommend using for finding out density, which I think misbehaves currently. And that should show the actual density of points by bins. And lately we've also supported hexagonal bins. Yeah, so you see, just like that. Oh, it got slower because it uses slightly different algorithm for hexagonal binning. Sometimes you want this, sometimes you want that. Yeah, we support both. Yeah, but that's
well. I mean, you sort of get that density effect because just if you use like sub-pixel or pixel to represent a point that sort of indirectly affects the visual saturation of a particular area. So you get sort of that as a side effect. Because if you have a huge number of points, quite often you just want to see the distribution over a 2D projection of them.
Yes, we did try multiple ways to do it. Very often there are edge cases that prevent you from seeing the distribution. For instance, when they fall on the exact same pixel, and then you just increase its brightness. But then there are other problems. So yeah, we've tried multiple things. So probably the best is a combination of density with each individual rendering. And of course, we do have the pixel rendering. So yeah, if I want to let's see, what did I want? Yeah, to add 10 million rows and then a scatter plot. Actually, by default, it would appear in the pixel mode. But you see, it didn't really give you the density that you saw on the other one. Yeah, these are individual pixels, and when you zoom, you sort of can assess the density, but not always. So, as usually, yeah, there are many trade-offs when you deal with data that big. That actually concludes my demo on scatter plots. Any other questions from anyone on scatter plots, or if you have other questions to the previous presenters, now is the time.
No, these have been some very interesting, exciting evolutions here that you're showing. So,
Yes, thanks, Ed. A lot of what is currently brewing is in the pipeline. Let me just make some minor teaser if it works, if we have it on a dev server. And that would be the topic of the next user group meeting in 3 months. A really rich medicinal chemistry data set that is sort of optimized for the DMTA cycles, where we show a lot of information, files, folders, plate viewers, dose response curves, and everything is interactive. On the fly, we make decisions, we track compound progress, we track decisions were made, we integrate with project management systems like Jira or anything else, and you get all of your information in one data set. And that's going to be one of the products, but today I'm just giving a teaser. Also check out how zooming will work. But yeah, let's keep it for the next user group meeting. So yeah, thanks for asking. I think it's time for us to close the meeting. Thanks everyone for attending. It was very interesting topic and engaging discussion, and that was our 20th meeting, so sort of an anniversary. I hope to see you next time in 3 months or so, but that's it for today, and have a great day.
thank you.
Bye, thank you.
Bye, everyone.
Bye.
Thanks, bye.
Bye.